In this lecture, we'll discuss about different types of angles which fall in pairs. First example, complementary angles. Any two angles whose sum is 90 degrees is called complementary angles. Now, first is, for example, 60 degrees and 30 degrees. When we say 60 degrees and 30 degrees, we have to add. For example, if they are falling separately, this is 60 degrees and this is 30 degrees. We can say these are separate angles but both are complementary to each other. And different way if we are just writing like this. For example, here it is 45 degrees and this also is 45 degrees. So when we are saying the sum of these two angles is 90 degrees, so they both are complementary to each other and they are called complementary angles. So they may share a common arm or they can be separate also. So any two angles whose sum is 90 degrees are known as complementary angles. Next type we will see in this, if the sum of two angles is 180 degrees, they are called supplementary angles. So supplementary angles also, if we say that any two angles, if they are falling in such a way that this angle and this one. For example, this is 150 degrees and this is 30 degrees. So both are forming a sum of 180 degrees, means they are supplementary to each other. Or if we are saying like this, any two angles. For example, if we take 120 degrees and another angle is 60 degrees. They are separate, but if we say these two are forming a sum of 180 degrees, so they are supplementary to each other. So like this, first is complementary and second type is supplementary. So what we have observed, these are two different types which fall in pairs. Means these two are forming one pair, 60 degree and 30 degrees forming one pair. Similarly, 120 degrees and 60 degrees. Here 150 and 30 degrees. Similarly, we will see different types of angles which are coming in pairs and the names are adjacent angles, linear pair, vertically opposite angles. So let's see the third type, that is adjacent angles. Adjacent angles also they share one arm. So if we say any two angles, for example, this is angle AOB and if we have just drawn one ray between this, means in the interior of the angle, that is point C. So these two angles, angle theta and angle alpha, these are called adjacent angles. Now the meaning of adjacent is, in parallelogram, it is different. Suppose we just draw a parallelogram and when I said the definition of adjacent angles, that is when they are sharing one common arm. But in this case, if we talk about the adjacent angles, then we will say these two angles, means angle A and angle D, they are sharing this arm in different way. So we can say angle A and angle D, they are also adjacent. Similarly, angle A and angle B and angle B and angle C, as well as angle C and angle D. So here the meaning is a little different. So like this or like this. Both are adjacent angles. Here they are sharing the common arm like this and here angle BAD you can say. Okay. So this arm is coming for this angle A also as well as for angle D also. So here also these are the pairs of angles which are called adjacent. Now the adjacent angles whose sum is equal to 180 degrees, they will form linear pair. So the next type is linear pair of angles. Means those adjacent angles like this whose sum is equal to 180 degrees. So if we say angle 1 and angle 2, they are adjacent. Why? Because they are sharing one arm, that is OC. So angle COA, or in other words angle 1, and angle COB, that is angle 2, they are adjacent as well as forming a linear pair. Linear means line. So on a line, okay, so angle 1 plus angle 2 is equal to 180 degrees. So we can say every linear pair is adjacent. But every adjacent pair means, for example, if I say these two angles, they are adjacent angles but they are not forming the linear pair. So every adjacent means the set of adjacent angles may not be forming a linear pair, but every linear pair will be adjacent. Now we will see some different types of angles which are formed by two lines and third transversal. Any two lines, if we draw like this, these are any two lines. They may intersect or they may not. And if a line intersects both the given lines, suppose that is line T, then there are some angles formed by this transversal on these lines. So we'll just number them. Angle 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 angles formed when two lines are intersected by the same line, that is called this line is called the transversal. Now here also we will discuss some pairs. Like this is outside here and this is outside. So that is called alternate exterior angle. That is called alternate exterior angles. Similarly, the next pair will be angle 1 and angle 7. So first pair is angle 2 and angle 8 in this alternate exterior angles, and the second one is angle 1 and angle 7. Both are on the exterior side but in the crossway. This is outside and this is also outside. These are exterior, but if we see crosswise, they are alternate exterior angles. Similarly, alternate interior angles. Angle 4 and angle 6. They are called alternate. Next type is alternate interior angles. Alternate interior angles means in a crossway only but inside. So angle 4 and angle 6. Similarly, angle 3 and angle 5. So they are also coming in pairs, angle 3 and angle 5. Now next type. The ones which are falling same side and same type means 2 and 6. They are upper side and on the same side of the transversal. So their name is corresponding angles. The next set is corresponding angles. So they are also in pairs. 2 and 6 are corresponding first set. Similarly, down same side 3 and 7. Second set is 3 and angle 7. Similarly, angle 1 and angle 5. Angle 1 and angle 5, and the next one is angle 4 and angle 8. So what we have observed, same side, same type, means 2 up and this also is up on the same side. So this is the combination 2 and 6, 3 and 7, 1 and 5, 4 and 8. They are called corresponding angles. And the last type is, they are called co-interior angles or consecutive interior angles. Co-interior angles are inside, means out of these four, but co-interior angles are on the same side of transversal and inside. So 3 and 6, angle 3 and angle 6, and the name is co-interior angles. Similarly, angle 4 and angle 5. So first set is angle 3 and angle 6. Second set is angle 4 and angle 5. So these what we have seen. These are different types of angles which are formed by this transversal. Means if any two lines are given and the third line, which is called transversal, intersects these two lines, then these are the pair of angles which are formed. Now further we will see. If these two lines are not any lines but specific lines, means if they are parallel lines, then these all angles what I have discussed, they are related. Okay, so next we will see when these angles are formed, what are the properties of those angles. Before we discuss different types of angles formed for the parallel lines, let's do some more concepts based on some axioms and theorems. Axiom is a proven statement. We don't have to prove it. It's a universal truth. So first is, if a line is drawn and a ray falls on that, then the formed two adjacent angles will be supplementary, or we can say their sum will be equal to 180 degrees. So a line AB is formed and a ray OC falls on that. Then these two angles, this is angle 1 and this is angle 2. So the axiom says that angle 1 plus angle 2 is equal to 180 degrees. And the converse is also an axiom. Converse means if two angles are formed in such a way their sum is equal to 180 degrees, then two arms, means OA and OB, will be formed in such a way that they will form a line. It means that if the line is given, then the sum will be 180 degrees for this ray which is drawn. Or opposite of that is, when the sum is already 180 degrees, then these two arms, OA and OB, they will form a straight line. So these are two axioms. Then next we will see a theorem. Theorem says that if two lines intersect, then different angles are formed and those angles' name is vertically opposite angles. So we will see one theorem which says that if any two lines intersect, like this, if we are taking two lines AB and CD, they are intersecting at point O. Four angles are formed. Angle 1, angle 2, angle 3 and angle 4. The theorem says that the vertically opposite angles are equal. Now which are the vertically opposite angles? Angle 1 and 3 are vertically opposite. Angle 4 and angle 2 are vertically opposite. Means they are equal. So whenever we write any theorem, so there are some steps. The very first thing is the statement of the theorem. So here the statement of the theorem is, if two lines intersect, then the vertically opposite angles are equal. This is the statement. After that, we have to write few more steps. The very important thing is the given part. Given means we will write symbolically what is given from the statement. Next comes what is to be proved. So to prove that is written in the short form TPT, to prove that, or simply TP also we can write. Next comes construction. Now this construction is optional, because to prove some theorems we require some constructions, means we have to draw some lines or we have to do some other parts, like it comes in the construction. The most important is the proof. That is the step in which we have to write the steps in such a way that they are based on some known facts. So here what is known to us are those two axioms. Means on a line, if ray falls, then the sum of two adjacent angles will be 180 degrees. So we can use that in this, clear? And we can also use the linear pair. So whichever fact we are using, we have to write the reason for that in the column of this proof. So now let's see what is given. Given is these two lines which are intersecting. So we can write AB and CD are two intersecting lines. Then what is to be proved? Whenever we represent any angle, it is better to represent it by number, because when we take the letters, it takes time to write and it takes time to read also. So better is to number the angles and proceed. Here what we have to prove? We have to prove angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Now figure is given. We have named the angles. We are not doing any construction. So that's why I told you construction step is optional. For this theorem, no construction is required. So we'll skip that. The last part is the proof. Now for the proof, we will take the help of axiom, as I said, or we can take the help of one concept called linear pair. This line AB. On this AB, OD is a ray which stands. So sum of these two angles will be 180 degrees. So we can write angle 1 plus angle 2 is equal to 180 degrees. Now here whenever you are writing any fact, any statement, it has to be reason out. Means you have to write the reason why are we taking this. So angle 1 plus angle 2 is equal to 180 degrees. There are different reasons. You can write the axiom which I said. You can write linear pair. Why linear pair? Because on a line, these two angles are adjacent and their sum is equal to 180 degrees. So linear pair. Okay. So any reason, whichever suits, you can write over here. Now similarly, CD is again a line and OB is a ray falls on that. So by same axiom, angle 2 plus angle 3 is also equal to 180 degrees. So angle 2 plus angle 3 is equal to 180 degrees. Now suppose you have written reason over here, axiom so and so and the statement of the axiom. Here you can write as above. Again and again we will not write the reason. Okay, once you have written, you can just say as above. Now compare these two. This is the first statement, this is the second one. The right hand side is equal, so that the left hand side will also be equal. Now the left hand side will be angle 1 plus 2 is equal to angle 2 plus angle 3. Both the sides, same quantities with the same signs, can be cancelled, or one way is there, we can say we can subtract the equals from the equals. That is from one other concept called Euclid's way. Okay, so that also you can apply, or directly you can say same quantity, same sign, both the sides can be cancelled. So angle 2 and angle 2, both the sides cancelled. What is left out? Angle 1 is equal to angle 3. This only we had to prove. Angle 1 is equal to angle 3. Now one part we have proved. Second part, for this particular thing, you don't have to prove. You can simply write similarly, angle 2 will be equal to angle 4. So what we have seen, when two lines intersect, the vertically opposite angles are equal. Now we'll discuss the types of angles which are formed for the parallel lines with the help of transversal. There are axioms and theorems based on those angles also. So first we will take two lines which are parallel and a transversal. Line AB is parallel to line CD. And if a transversal intersects both the lines, which is EF, then 8 angles are formed. Now the axiom says, if two lines are parallel and a transversal intersects, then the corresponding angles are equal and its converse is also true. Means if the corresponding angles are equal, then the lines will be parallel. Now let's see which are the corresponding angles. Angle 1 and 5, first pair. So first of all, we have to see what is the axiom. So as I said, if the lines are parallel, then the corresponding angles are equal. So by that axiom, symbolically, how will we write? Angle 1 is equal to angle 5, first set. Then angle 4 is equal to angle 8. Angle 2 is equal to angle 6 and angle 3 is equal to angle 7. The reason is same. What reason will we write? We will write AB is parallel to CD. Then corresponding angles are equal in one way. And converse of that, if corresponding angles are equal, then the lines are parallel. This is the first and the second axiom. Lines are parallel, corresponding angles equal. Corresponding angles are equal, then the lines are parallel. Now after this we will see some more types of angles and the theorems based on that. So the first theorem, it says that when the lines are parallel, then the alternate angles are equal. So first we will see which are the alternate angles. Alternate angles, interior alternate angles, angle 3 and angle 5, first set. Second pair is angle 4 and angle 6. So we will prove by the known facts. So the theorem says if the lines are parallel, so statement is when the two lines are parallel and a transversal intersects it in them, then the alternate interior angles are equal. So for this theorem, what is given? Given is AB is parallel to CD and EF is the transversal. What is to be proved according to this theorem? Alternate interior angles are equal. So symbolically, if you write, that would be angle 3 is equal to angle 5 and angle 4 is equal to angle 6. Now, for angle 3 and angle 5, if we see, what do we know? Previously we have done, if two lines intersect, the vertically opposite angles are equal, and if two lines are parallel, the corresponding angles are equal. So we can take help of these two known facts to us. Now, it is to be proved 3 and 5 equal, but 5 is an angle which is equal to this angle 1. Why? Because the lines are parallel and these two angles are corresponding angles. So what will we prove? Angle 3 and angle 1 are equal. Angle 3 and angle 1 both are equal. Why? Because these two are intersecting lines and vertically opposite angles are equal. So angle 3 is equal to angle 1. But angle 1 and angle 5 are equal. So two statements we are getting. Angle 3 is equal to angle 1. Angle 1 is equal to angle 5 and we will equate them. So ultimately what will we get? Angle 3 and angle 5 are equal. We have to write the reason for each step. Because when we say angle 3 and angle 1 is equal, so there is a question why. So that why has got a reason. So here for the proof, first we will say angle 3 is equal to angle 1. Now, normally people write vertically opposite angles. That is not the full reason. We have to write the reason fully. Means vertically opposite angles are equal. Vertically opposite angles are also written in short form VOA. Vertically opposite angles are equal. This is the full reason. Okay. Now, after this we can say angle 5 and angle 1 are equal. Angle 5 and angle 1 are equal. The reason is corresponding angles are equal. Corresponding angles are equal. Now compare this and this. Both the statements, right hand side equal, so left hand side will also be equal. So on comparing, you can name it. This is 1 and this is 2. So on comparing 1 and 2, we can say angle 3 is equal to angle 5. This only we wanted, that if the lines are parallel, the interior alternate angles will be equal. Now after this, as I said, you can simply write similarly. Angle 4 is equal to angle 6. So this is a theorem. Okay. Now after this, we will do another theorem based on the angles and for the parallel lines. In the previous theorem, we saw that if the lines are parallel, the alternate interior angles are equal. The converse is also true. It means if the alternate interior angles are equal, then the lines will be parallel. So what we have seen, that if AB is parallel to CD, this implies angle 3 is equal to angle 5 and angle 4 is equal to angle 6. And the converse says if angle 3 is equal to angle 5 and angle 4 is equal to angle 6, then the lines will be parallel. So we will see there is a theorem and its converse. Now the next theorem is based on co-interior angles. Co-interior angles are also called consecutive interior angles, or the interior angles formed on the same side of the transversal. The theorem says that if two lines are parallel, then the co-interior angles are supplementary. It means the interior angles formed on the same side of the transversal are supplementary, means their sum is equal to 180 degrees. So for this theorem, given is AB parallel to CD, this is given, and we have to prove angle 4 plus angle 5 is equal to 180 degrees, and next set, same side we have to take, angle 3 plus angle 6 is equal to 180 degrees. So one set we will take and next we will write similarly. Angle 4 plus angle 5 we have to prove equal to 180 degrees. Now we will see how is this 4 related to this angle 1 whose sum is 180. We had done one axiom. This is a line, this is a ray. Okay, just name this point as O. So for this EF, BO is a ray. So by the axiom, angle 1 plus angle 4 is equal to 180 degrees. And also I told you, you can apply the concept of linear pair. So by linear pair or by axiom, angle 1 plus angle 4 is equal to 180 degrees. Always remember, whenever there is no construction part, we will just skip that point and we will directly do the proof of the theorem. So in the proof, what are we taking? Angle 4 plus angle 1 is equal to 180 degrees. Either I said you write linear pair or you write axiom. Okay. Now, angle 1 and angle 5. What type of angles are they? Corresponding angles. So, angle 1 is equal to angle 5. The reason is corresponding angles are equal. Now compare angle 1 and angle 5 are equal. We are saying angle 4 plus angle 1 is 180, but angle 1 is actually equal to angle 5. So we will replace this angle 1 by angle 5. So from 1 and 2, angle 4 plus angle 5 is equal to 180 degrees. What we have taken? We have taken these two steps in which we have replaced this 1 by this 5 because angle 1 is equal to angle 5. So what have we observed? Angle 4 plus angle 5 is equal to 180 degrees. So this is one set. We will simply write similarly. Similarly, short form SLY also you can write. Similarly, angle 3 plus angle 6 is equal to 180 degrees. So what we have seen, if the lines are parallel, then the co-interior angles are supplementary, and the converse is also true. We can say if for any two lines co-interior angles are supplementary, then the lines will be parallel. So this is all about the angles which are formed for parallel lines with the help of transversal. we have seen the axioms and the theorems based on the same. Now there is the theorem for parallel lines. If two lines are parallel to the same line, then they will be parallel to each other. Means, theorem says if any two lines, suppose line L and line M are given, which are parallel to the same line, means same third line. So third line is this N. So what is given? Given is L is parallel to N first, then M is also parallel to N. Theorem says that if two lines are parallel to the same line, that same line is N, then they are parallel to each other. Means what we have to prove is L is parallel to N. For that we will do one construction. That construction is we will draw one transversal. You can simply say T is a transversal which intersects all three lines. Now, what is given? Given is L parallel to N and M parallel to N. We have to prove L is parallel to M. Now there are some angles formed by this transversal on all three lines. So we will name them angle 1, angle 2 and angle 3. One set at a time we will take. Okay. Before we come to the proof, as I said, if we are doing some construction, we have to specify. Now we have to do one construction. So that we will write T is a transversal. So we can simply say draw T as a transversal. Now for the proof, angle 1 will be equal to angle 3. What is the reason? Corresponding angles are equal. So we can specify here corresponding angles are equal. Similarly, angle 2 and angle 3 will also be equal. Why? It is given that M is parallel to N. So angle 2 is equal to angle 3 with the same reason. Corresponding angles are equal. So angle 1 is equal to angle 3. Angle 2 is also equal to angle 3. So combine these two. This will give us angle 1 is equal to angle 2. But what are these angle 1 and 2 for the lines L and M? They are the corresponding angles. So what we had seen, if the lines are parallel, corresponding angles are equal. But if the corresponding angles are equal, then the lines will be parallel. So what have we got? Angle 1 and angle 2. So what will be the reason? We will write the reason. Since these are corresponding angles for lines L and M. Therefore, L is parallel to M because corresponding angles we have proved equal, and when corresponding angles are equal, the lines should be parallel. So what we have seen, the two lines which are parallel to the same line will be parallel to each other. So these are the theorems for the parallel lines and the angles formed for all these. Now we'll do theorems based on triangle. Angle sum property of a triangle, it says that the sum of three angles, means interior angles of a triangle, is 180 degrees. So we will take one triangle and given is a triangle and we have to prove angle A plus angle B plus angle C is equal to 180 degrees. First is the theorem, and in the theorem, the very first thing is the statement of the theorem. So here the statement of theorem is, in a triangle, the sum of three interior angles is equal to 180 degrees. This is called the angle sum property of a triangle. So that is given a triangle ABC, and we have to prove angle A plus angle B plus angle C is equal to 180 degrees. Here we will do one construction. We will draw a line which is passing through this vertex A and parallel to BC. So that will go under the column construction. So that is a line passing through the vertex A and parallel to BC. The next column will be construction. In construction we will write draw a line L parallel to BC. Now we will take help of the angles formed in the parallel lines, the transversal. Here we have to prove angle A. Now we cannot say here angle A. Why? Because as we have drawn this line, there are two more angles formed on this vertex A. So for that we will number the angles. So this is number 1, and if we are taking this as 2 and this as 3. So in other words, we can write, we have to prove that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. This is the same column what we have to prove. We have just numbered the angles. Now, this line L is parallel to this line BC and AB will be the transversal. So the minute we see the parallel lines and the transversal, all the types of angles, corresponding angles are equal, alternate interior angles are equal, co-interior angles are supplementary. So here when the lines are parallel, we can take help of alternate angles. So this angle that we will number it after 3, that is 4, and this angle we will number as 5. Now, since the lines are parallel, so angle 4 and angle 2 will be equal alternate interior angles. Angle 5 and angle 3 are also equal with the same reason. Alternate interior angles are equal. Now, look at this angle 4, 1 and 5. The meaning of a straight angle, that is, when we draw a line, a straight line, the angle formed on either side, either this side or this side, that would be equal to 180 degrees. And on this line, if we draw some rays, then too, the sum of all these angles will also be 180 degrees. The same type of situation is here. Angle 5 plus angle 1 plus angle 4. These all three angles are drawn on the same side of this line L. So angle 4 plus angle 1 plus angle 5 will be equal to 180 degrees. And what is the reason? Straight angle, because they are formed on the straight line. So we can say for the proof, first we will write angle 4 plus angle 1 plus angle 5 is equal to 180 degrees. The reason is straight angle. Okay. Now we will replace this 4 with this 2, 5 with this 3. But before that we will write why are they equal. So angle 4 is equal to angle 2 and angle 5 is equal to angle 3. We will write the reason that L is parallel to BC, that is by construction, and here we will write these angles are alternate interior angles. And since the lines are parallel, so the alternate interior angles are equal. Now further we will replace in this 4 by 2. So ultimately in this 4 plus 1 plus 5, in place of 4 we will write 2, 1 will be as it is, in place of 5 we will write 3. So what have we got? Angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. So what we have seen in a triangle, the sum of 3 interior angles is equal to 180 degrees. Now we'll do one theorem which is based on exterior angles of the triangle. If we extend any of the sides of the triangle, 3 exterior angles will be formed. But the relation is here for 1 exterior angle and the opposite 2 interior angles. But the possibility is for any triangle, we can extend or we can produce any side. First possibility is, suppose I have produced this side BC. So here this exterior angle is formed, or In this way, I have extended this CA, so this exterior angle is, BA, and this exterior angle is formed. Or if I have drawn like this, then on extending this CA, this exterior angle is formed. So any of the sides can be extended. If we have produced or extended one side of a triangle, then what we are observing, an exterior angle is formed. So this theorem says that if a side of a triangle is produced, then the formed exterior angle is equal to sum of two opposite interior angles. There are three interior angles, but this we will leave, which is adjacent to this exterior angle. So other two left out are these two angles. So what we have to prove, that this angle 1, that is formed by extending the side of this triangle, that is equal to the sum of two opposite interior angles. Here in this case, if we want to say, this angle 1 should be equal to angle B plus angle C. Similarly here, if we will extend this side CA, and this exterior angle is formed, so that should be equal to angle B plus angle C. First case, one case we will take, and it is true for all. So the statement of theorem is the exterior angle is equal to sum of two opposite interior angles. So for this theorem, given is a triangle ABC in which we have extended or produced this side BC up to, suppose, D. So we can say BC is produced. This is given, and we have to prove angle 1 is equal to angle A plus angle B. This we have to prove. Now, to prove this, with this one adjacent angle is there, and that is forming a linear pair also. Why? Because this BC is a straight line and we have extended it. So ultimately this BD is a straight line, and on a line, two adjacent angles, their sum will be equal to 180 degrees. Okay, because they are formed on this line, or simply we can say straight angle also, because sum of these two, they are formed on the line, will also be will be equal to 180 degrees. So we can say, for the proof, angle 1 plus angle 2 is equal to 180 degrees. We can say by the fact linear pair, or we can say straight angle also. Any reason you can write. Now, angle A plus angle B plus angle 2 is equal to 180 degrees by the previous theorem, angle sum property of a triangle. So we will write angle A plus angle B plus angle 2 is equal to 180 degrees, angle sum property of triangle, like this in short we can mention. Now look at these two equations. Both are having the right hand side equal. So the left hand side will also be equal. So here we will see angle 1 plus angle 2 is equal to angle A plus angle B plus angle 2. Now angle 2 and angle 2, both the sides same sign, same value, can be cancelled. So what we have got, angle 1 is equal to angle A plus angle B. That only we had to prove. So exterior angle formed by producing the side of the triangle is equal to sum of two opposite interior angles. So this is the theorem which is called exterior angle theorem.